On this week's episode of This Week in Space, we're looking at rogue planets that wander space until they smack into a planet like ours, perhaps? Join us.
Podcasts you love.
From people you trust.
This is Twit.
This is This Week in Space, episode number 126, recorded on August 30th, 2024. Danger, rogue planets. Hello and welcome to another episode of This Week in Space, the Rogue Planets edition. Yes, and it's as scary as it sounds. Well, I think it is. We'll find out. I'm Rod Pyle, editor-in-chief of Ad Astra Magazine. I'm here with the one and only Tarek Malik.
Surprise, surprise, I made it. I made it this week.
Editor-in-chief at space.com, who is supposed to not be with us, but at the last minute made it. So thank you for coming, Tarek. We appreciate it.
I'm glad to be here. Glad to be here, Rod. As always. And with all our space fan listeners, of course.
And as you may have guessed, today we're going to be talking about rogue planets and their implications, all that contains, with Dr. Rosalba Perna, professor of physics and astronomy at Stony Brook University, and she'll be joining us shortly. But before that, we'd like to ask you once again, as I always do us a solid, make sure to like, subscribe, and all the other podcast goodies to our podcast so we can continue to bring you this enlightening information in a way that is so unique to us. And speaking of unique to us, we have another space joke from listener Martin Harris, who graced us last week. Are you ready, my friend?
I am ready, yes.
What did Orion get when it came last in the race?
I don't know. What did Orion get?
He got a constellation prize.
I love it. That's good.
Hey, all six of our fans liked it too. Thank you, six fans. We appreciate that. Okay, yes, thank you, Martin. Much appreciated. And for the rest of you, get on it and send us those space jokes so that you don't have to listen to mine. Okay, so let's do some headlines, and we'll start with, it's an easy guess, Starliner.
Hey, it's coming home.
We have a date.
It's right. That's right. Finally, at long last, what, three months after it launched into space, Starliner will return home just after Labor Day weekend. You know, but I guess Boeing found out it's not kosher to wear white after Labor Day, so they're bringing their blue and white space capsule back to Earth. This is obviously from space.com, but everyone else was reporting it too. Mm-hmm. NASA and Boeing have set September 6th, which is next Friday, Rod, right hours after you and I record our next episode. Boeing will return to Earth. And so we're going to find out how it all goes. But mark your calendars because you're going to be able to watch it live late Friday night. The action will happen. I think it undocks around 6 and it lands around 12 a.m. on Saturday. So it's going to be a pretty interesting time. Coming back empty as well, as we all remember. And in fact, NASA just announced who is going to be flying up on Crew 9 and who lost their seats. And right now it's Nick Hague and the Russian cosmonaut who are flying. And that means that Zanik Hardman and the other crew member will have to wait for their next flight. So
it's an interesting contrast. So we've got this Starliner drama going on, and again, hopefully they'll get things straightened out. Hopefully it'll come back fine. Hopefully this was an overabundance of caution, which is always a good thing if you're flying people in space.
Yeah. And
hopefully they move forward and they are able to at least fly out their 6 flights with this thing before the space station is ended. But in a kind of stunning contrast, at the same time all this is going on, SpaceX is flying professional tourists up in orbit with Isaacman to go higher than anybody's gone since Gemini 11 or the Apollo program. And I don't know, you just look at that. They're not related, and I get that. But you've got the Dragon doing yeoman work very admirably. And, hopefully it will continue to keep doing that. And I'll let you draw your own conclusions. I saw that. And immediately after that, I read a Starliner article and I thought these things don't transpose well.
For perspective, the next launch in September of NASA crew on SpaceX Dragon will be their 10th crewed flight for NASA. And I think they've launched 4 other private flights already with AX 1 through 3 plus Inspiration 4. So that's a lot. That's a lot.
We'll let that speak for itself. Okay, moving on. Speaking of SpaceX, not all is wine and roses.
That's
they
right.
had a record-setting 23rd flight for one of their boosters that I think flew the first crew flight, right?
It flew Inspiration 4. It flew Demo 2, I believe,
That was
which was the crewed flight, plus something like 16 or something different
But
Starlink.
it won't be flying anymore.
No,
Well, maybe
no.
not. Actually, they may retire it.
No. It is not flying anymore. In fact, on line 22, John, you can see what remains of booster 1062. Not a lot. Is the message there? Photographer John Krause got shots of it coming back on the drone ship. But this is as you explained, Boeing's not Boeing's. I haven't had enough coffee yet. SpaceX's most flown
That was Freudian.
booster. I tell you. Booster 1062. This was, going to be like their big 23rd
Oh, my.
landing. Yeah,
There's
and
not much left of that thing, is there?
no, it launched a Starlink mission on the 28th, really early in the morning on the 28th. Perfectly, mission went fine. Deployed the payloads fine, but when it was trying to land, something happened. It looked like one of the leg struts buckled, and the thing toppled over. It also looked like it caught fire as well, and it tipped on its side. You saw a big splash in the ocean, and then the feed cut to black. It looks like it just broke in half or blew up or whatever, and you still have those Merlin engines there. It'd be interesting to see what SpaceX does with this, or if Jared Isaacman, billionaire Polaris Dawn commander who flew on this booster, buys it and like mounts it. I don't know where you would.
Oh
mount
no, I think
that.
Steve Jurvetson will buy it.
Yeah,
And
So-
he'll make an office chair out of it or something. You know what's weird? Excuse me for jumping into it.
Yeah.
but One of the press accounts I read, and it was from one of the more reputable outlets, I think.
So not space.com. Heyo.
Well, it wasn't you guys. I don't think quoted SpaceX as saying we'll evaluate it for possible reuse. So I don't know if that was before they saw what was actually on the barge, or
It could be. Those are beefy rocket engines. There could be something that they might be able to requalify after it, but they're going to look at it to see like what happened for sure. And we've been talking a lot about, oh, this is so atypical. I think it's their first failed landing since 2013. Something
Yeah.
like that. A long time.
Right.
It's been since they missed a landing.
260 something successful landings, right?
Exactly. And the one wrinkle is that the FAA announced shortly after the failure that they want to investigate it. I guess to make sure that there wasn't any issue with the booster itself from launch that could have caused it, which would have affected all other SpaceX missions. But SpaceX stood down from a second Starlink on this same day. And their Polaris Dawn mission, which we're going to talk about in a bit, also has been pending.
And let's make that not a bit. Let's make that now. Polaris
Yeah.
Dawn delayed again. Darn it.
Delayed again by weather, apparently this time. So
Yeah.
this is the mission we were alerting to earlier. Billionaire Jared Isaacman bought another trip to space with SpaceX. Actually, this is the first of 3 trips under the Polaris program, Polaris Dawn, to attempt the first ever private spacewalk, fly higher. Like the highest mission since Apollo 17, actually in 1972, and then hopefully just break a bunch of records across the board. They were delayed by helium leaks on the ground, then again by more rocket checks, and then by weather at the splashdown site 5 days after launch. They want the forecasts are really bad apparently for that. They want those waves to be low so then they go recover the crew easily. And after they delayed the launch from, I think it was the 28th they were looking for, they're just pending. They don't know when the weather is going to look good for landing. Now, it's really strange that they haven't said that it's delayed because the FAA has kind of grounded SpaceX's launches from that booster failure from the landing. But we'll have to see if that has any kind of impact on that. Both SpaceX and Jared Isaacman have said it's really just the weather, that they're still in quarantine, this private crew, and they're hoping to fly as soon as they get word.
All right, and let's wrap this up with we have some additional information on the failure of Astrobotics Peregrine lander. No, Intuitive Machines Peregrine lander, right?
No, it was Astrobotics. You are
Astrobotics,
correct.
yeah.
Yeah. Astrobotics, they had a
If I
press
say it enough
conference.
times, I get it right.
They had a press conference this week to talk about what exactly failed on the Peregrine moon lander when they launched it on January 8th this year, which was the first flight of the United Launch Alliance's Vulcan rocket. And as our listeners might remember, they never actually were able to reach it to the moon with the lander. It had a failure after separating from the rocket, and the engines, had problems, and they were never able to make the orbit to reach the moon. And instead, it came back to Earth. I think it re-entered the atmosphere on the 18th and burned up. R.I.P. Peregrine lander. And so what they said this week is that they've pinned it down to what sounds like more leaks on a private vehicle and a faulty valve that wasn't sealed properly. And because of that, it kind of messed up the engine itself. They weren't able to use it properly. You can't use your engine properly. You can't maintain your orbit. You can't do your orbit changes to leave Earth orbit. And that's what kind of spoiled the entire thing. It is a bit disappointing because as they were getting ready for their next mission, NASA's Viper rover, NASA canceled that mission too. So they're kind of in a bit of a quandary to try to figure out what the next steps are going to be. But at least they know, at least as conclusively as they can, what went wrong with Peregrine, how to make the next one a bit better, and maybe offer some consolation rides to the customers who lost their trip to the moon.
Very good. All right. Well, we're all caught up. Thank you for that, my friend. And we will be back after this short break with Dr. Rosalba Perna. Stand by. And we are back with Dr. Rosalba Perna. Thank you for joining us today, Rosalba. We really appreciate it.
Thank you for inviting.
So you are a professor of physics and astronomy at Stony Brook University, which always impresses me. I was in astronomy. Actually, I think both Tarek and I were trying to be astronomers at one point in our lives.
Desperately
and
trying.
When we discovered how much math there was, we decided to be journalists instead. So my hat's off to you, especially as an astrophysicist. I have a question about your teaching, if I may. This is kind of an aside. But I took every astronomy class possible at UCLA and a college I went to before that. And at least in the first couple of introductory classes, the dropout rate was about 60%, which might have had something to do with the professor we had. He was kind of tough. But I found later, talking to them, that about half those people that dropped out had thought they were going into a class on astrology. Huh. And when they discovered it was science, they were like, well, this isn't what I wanted to study. Has that ever happened to you?
It's actually very funny because one of the classes that I teach, and if, some are this 100 level, there are sometimes students that come with the idea that there is, the professor, there's absolutely no math, meaning no algebra. And those are, just algebra that is there. But also, that maybe it's more about, constellation. So I actually have a slide in the intro day that said, well, this class is not, and I put, it's not astrology. So it's...
So you let them know early enough.
So let them know right away. Exactly.
Drop out and get your money back. And I just want to read this brief bit because it was so impressive. And I hope I pronounce all the words correctly. Your research interests include theoretical astrophysics, magnetohydrodynamics, and turbulence in the atmospheres of hot Jupiters, dynamical effects from stellar encounters on planetary systems, and I think another paragraph or so of material. Did I get that right?
Yeah, it's I like to work on different things. Yes.
That's very modest of you. So we are here today specifically because I saw a paper you did and an article on it about rogue planets, which of course is a great title because it sounds frightening. These planets that have detached or been created outside of star systems as we traditionally understand them and are hurtling through space, dark and scary, and who knows where they're going to show up, and what if one comes to our solar system and all that. Ooh. So those are a number of suppositions that you're going to have a chance to correct over and over again as we go into this. But I think before we get into what they are and how they form, the question that'll be at the front of everybody's mind is, could one of these come close enough to our solar system to create a disturbance sufficient to That's what we all wonder about.
Well, before that, can we ask how she got into space, though, Rod? Yeah. I'm very interested in everyone's path to space, and so is it something that you were a bit like as a youth, or?
It's an interesting question because I kind of never remember the time I decided I wanted to do astrophysics because I feel like I always knew when I was 5 years old. My parents remember that I was just started to read and write. And I said that I like the universe. I wanted to be a scientist, and that never changed. So I never had the moment where I say, okay, what am I doing? What I want in the future, or sometimes a spiritual teacher, or I don't know where it came from because neither my parents is a scientist. They were elementary school teachers, so they were puzzled themselves about me wanting to be a scientist already 5 years old. So I feel lucky that it was, I get to do for work, what it was always my passion. So it's
Well, that's what I always tell my daughter: find what you love and find a way to get money for it.
yeah,
make it a career.
It's the best. That's the best. Yes.
So did you know kind of what direction you wanted to take once you got into undergraduate school?
So so I was like physics, so that was undergrad. So yeah, it never, again, there was not a thought of what am I doing. It was like, okay, I'm doing physics and then specialize in astrophysics. So it was, new forever.
Okay, so Tarek, are you satisfied now? Can I
Yeah. I'm sorry, I don't mean to interrupt. Good. I like the path as all.
Are rogue planets a threat to us?
Right. So it's so the interesting. So these rogue planets are, just to put in context for everyone, are worlds. They are untouched to any stars, so they're free floating in space. And one of the questions that if one were to approach our system, what would happen? So there is two answers to that. One, that the likelihood that one of these would approach us are probably rather low. So it wouldn't. So that's the first thing. But it's also, if there is, an old spectrum of, as we get into it, most likely, of rogue planets in terms of masses, some which are more Earth-like, others that are more Jupiter-like. But the ones that, from recent surveys, seem to be more abundant are the tiny ones. So then if a tiny one were to, to come close by, it wouldn't be as dramatic, like if instead it were more like a Jupiter one. Mm-hmm. But the probability that the free-floating Jupiter approaches our solar system right now, they're not very high. So we are not in a super dense environment, unlike other systems that start forming regions which are very, very dense and where there's a lot of chaotic interactions and flybys, which can eject planets and disrupt planetary systems.
Well, I think that's my next question there, Rosalba, is what exactly is a rogue planet? Like, is it one that gets kicked out of its solar system? Is it one that forms in the vastness of space all by itself in the dark, which sounds really sad, but also like an average Saturday for me, sadly. But so what to you as a scientist do you classify as a rogue planet? Because it sounds like there isn't like a size.
Right. Well, so there is in terms of so as far as like observational. So these planets were not theoretically predicted, so they started to be discovered, and now we're trying to make sense. So going to the question of what where they're coming from, which I'll get next. So this rogue planet again. So there are isolated objects that we see, and we have seen in both the Jupiter-like ones as well as the small Earth-like ones. So where we are is, so first of all, where we classify in terms of masses as far as planets, it's usually below 13 Jupiter masses. Above that, so about between 13 and 8, roughly 75 or 80 solar masses, we are in the regime of brown dwarfs. So brown dwarfs are, in other words, they're failed stars. They're objects that started the process of formation very similar to stars, that is by collapsing as a cloud. And while stars are able to collapse to a level at which that center region becomes hot enough to ignite fusion. In the case of brown dwarfs, that doesn't happen. The fusion of helium of hydrogen to helium doesn't happen. So that requires a minimum mass, which is on the order of 80 Jupiter masses. So above that, we can form a star. Below that, there are objects which we call brown dwarfs, which again cannot ignite hydrogen into helium, but they can ignite deuterium. And that goes all the way down to about 13 Jupiter masses. So this is the brown dwarf range. So we call planets. Sorry, going to the question. So it's a more, astronomical definition. It's something below basically 13 Jupiter masses. So those were planets in terms of mass. Therefore, there is a continuum as far as what we see in terms of these rogue worlds. So there are a lot of brown dwarfs that are out there isolated. Now, what forms them? So that's a big question that astronomers have been asking. And there are various mechanisms that have been proposed over time. So something that can happen. So when the solar system, so assuming that planets form in a solar system, as we believe in standard theory, our understanding of the sun and its planets, we transpose it out there. But something that we know, and we know also from our solar system, that the early phases are very chaotic. Right, now the solar system is relatively tight with planets going into, quite in their orbits. We have a bunch of small objects that are, however, very confined in belts. They're there. But once upon a time, when the system was formed, there was a lot more chaos and motion. There were many more of these asteroids and smaller debris that were floating around and kicking. And we see some remnants of that in our solar system, as a matter of fact. Like the axis of Uranus, for example, is tilted. If we look at the surface of planets like Mercury, it has a lot of craters. So those are craters of bombardments from the past. So we know that there was a lot of chaos. And in all of that, also planet-planet dynamical interaction become important. And if you have a giant planet like a Jupiter one approaching a smaller one, in this process of interacting, over the smaller ones are being kicked out. So that's one mechanism. It's the most straightforward one, so to speak, and it's something that theorists have been able to reproduce with numerical simulations. So they simulate star-forming systems, and they see that in this dynamical interaction there are some ejection, preferentially of smaller planets.
Well, speaking of fusing hydrogen and making things burn, I have a burning question that I'm going to ask as soon as we take this break. Wasn't that clever? We'll be right back, so don't go anywhere. So I read in one or more of the articles that the Webb Space Telescope has been a real gift to searching for these things. And that I think it was a Webb discovery, was that a lot of them are binary systems.
Yeah.
Raises a whole bunch of questions. If these things are booted out of existing solar systems as part of planetary formation and their evolution, why in pairs? Does anybody know?
Right. So that's a big question. So it was it was a very unexpected discovery of the James Webb, and something I should say as a start that they're still called candidates. There's been they were observed in the Orion Nebula, they observed about 500 of free-floating single planets, and among those, 40 were.
That was in the Orion Nebula, you said?
That was in the Orion Nebula, the trapezium cluster, which is a particularly dense region within the Orion Nebula. So they are still in the process of being confirmed because they were observed photometrically, so they see the color, but there can be degeneracy. So dim colors could be a planet, but it could also be a star which is partly obscured, and so forth. So that's just something to keep in mind, because as astronomers we're now we're waiting for confirmation, because they are whether they're all of them or if it's a fraction of them, that carries quite a bit of implication for theoretical models. So, because from a theoretical point of view, there was no prediction of any of this, and so given the observations or this, candidate observations, theorists have been obviously very interested, like myself, in trying to figure out a mechanism by which they could be formed. And so there are a number of ideas, and one I worked on with my former grad student Ian Wang, who is now a postdoc at University of Nevada. related to the fact that, well, the planets are formed in a normal solar system, so to speak. So that's that we know. The one thing is that they have to be in relatively outer orbits, which we see. We see a fraction of planets at orbits of several hundred AU. AU is the distance between the Earth and the Sun. So many hundreds of times the distance from the Sun for this planet. So they have to be already be outside. But then, as a star passes by, which happens, relatively higher frequency, the denser a cluster is, then there can be ejection so the star is basically giving a kick during the process. And in this dynamical interaction, well, very often single planets are ejected, but ever so often, if the orbits of the two planets, of the two outer planets, are relatively close by at the moment of the interaction, an ejection can happen and lead to a binary. So that's one mechanism that was proposed a posteriori for try to explain it. I
was gonna say, can you really be a rogue planet if you're a binary though? Because like rogue planets to me are like Batman; they only work alone. And and if you've got a binary, then you've got a friend.
You have
so
a friend,
you're not
right?
rogue at all.
Yeah, so I guess it's free floating, right? It's you're.
But I had a kind of a related question, Rosalba, because.
Way to bring it to the masses, brother.
Right. Well, I'm just saying, right? Because we talk a lot about these rogue worlds, but I'm wondering, like, what if one of these planets has like its own moon, or like a whole bunch of moons, like Saturn or Jupiter? Do those get ejected with it?
So that's it's an excellent question indeed, because I started with one model that I work on, but then again there can be other mechanisms, which is exactly as you're saying. So if you have two, assuming that the two, normally the moons tend to be smaller than the planets, but one could imagine a system where you have a planet and then its own moon is, relatively sizable compared to the mass of the planet. And then when you have an ejector, it will work almost like a single ejection, and you eject the two at the same time. So it's a similar mechanism, except that they are already in a binary within the solar system. So that's one other possible mechanism that could work. And then there is, the possibility that they were formed in situ, like, brown dwarf, like stars and brown dwarf. But that's one that, in principle, one can make as many as one wants. In practice, there are theoretical difficulties with that. So even for forming single planets below a certain mass, which is believed to be around three Jupiter masses, clouds, as they collapse, they become unable to cool. So there is a condition called opacity limit, which basically they can't get rid of their heat fast enough, and therefore they stop collapsing. And that happens around 3 Jupiter masses. So it's believed that unless there are unusual circumstances, like you have a supernova exploding nearby, and therefore you have an extra punch to make it compress, they would not naturally form in situ. And then even more so, like imagine it's hard to form one, imagine two as a binary. So mechanism by which, is the one you suggested, or, others where planets were formed, as we believe, in a planetary system, and then they went into outer space as a binary. So those are, those are possibilities. Again, unless, in situ, one find ways to bypass astrophysical limits that don't suggest that the formation to be natural. There is also another set of observation that astronomers have noticed. So usually stars come in pairs. So there be in situ massive stars that actually, the abundance, it's a very high, it's more than 50%. But then what astronomers observe is that as one goes lower and lower in mass, the binarity fraction becomes lower and lower and lower. So, brown dwarfs, for example, have much low binary fraction. So it seems a bit unnatural. Again, it's not impossible, but it's unnatural that you have a trend over order, magnitude, and scale in binarity, then turns around when you go to the very low mass, where it actually there is a reverse, and the binarity starts increasing with decreasing mass. So that has been another puzzle, and one that would have to be explained if these observations are confirmed.
All right. I do have a question, but we have to go to another break, so stay with us. We'll be right back. So this question comes from a friend of the show, Isaac Arthur, who has a very popular YouTube channel called Science and Futurism with Isaac Arthur, and we love Isaac. So he asked me to ask, if you have a larger rogue planet, say a gas giant, like some of them appear to be, if it had moons, could they be affected by tidal forces like we see with moons like Enceladus and Europa in our own solar system, and possibly have warm oceans underneath?
Yeah, I mean, absolutely. So that's, tidal effects work everywhere. Either these giant planets are attached, they are within a solar system, or if they're isolated. So that would be very interesting. It's only, what matters is the distance. So because tidal effects are a function, like, gravitational forces, it depends on the distance and the composition to a certain extent. So the more compressible the material of the moon, the easier it is to be subject to tidal effects at the same distance. But it could be like Europa if we were to find.
So would an icy crust be more compressible than a rocky crust, for instance?
Right. You're right. Yeah, icy. It's more compressible than rocks, indeed.
Or sponge cake.
Sorry,
go ahead.
That would be an interesting moon.
I had seen a lot of talk a few years ago, Rosalba, about the role that dark matter might play in rogue planets, just because we can't see it. We want to know where it is. Yeah, maybe it's hiding in these rogue planets. Is that still a viable theory, that like there is there are that's where all the dark matter is hiding in these planets we haven't been able to detect as much?
So that's it's a very good question indeed, because it's in a way the discovery of some of these rock planets that happen via macrolensing. So some have been discovered as we were saying before, with direct imaging with James Webb, but actually in all other sets, especially the smaller, dimmer ones, have been detected via microlensing. So microlensing, just as a refresher, it's a phenomenon by which it's a result of the theory of general relativity, by which light is deflected by a massive object, and it results in double images and an amplification. Now, when the object that's doing the lensing is small, we don't see the effect of the double images, but we do see the amplification. So astronomers looking for potential dark matter candidates, which indeed could there be any sort of like black holes, for example, that were a candidate with, free floating in space, or again, brown dwarfs, which after a while cool completely. The only way to see them is via their gravitational effects. So there have been searches to this effect. And the result is that they would make up only, I believe remember from the latest survey, up to %. So unfortunately, dark matter still remains a mystery. But in the process, we have actually discovered, a number of these rogue planets. So they cannot make a dark matter, but it was an interesting, definitely an interesting possibility, at least for, brown dwarfs. They're also more massive, so they could make more. So the two searches that were, sorry.
No, go ahead.
No, I was saying it, yeah.
Okay, you guys, come on, take a turn, quick.
Yeah. So let me. I have. Is this a good time for my list of questions, Rod? I have a lot of like, I think they're kind of silly questions, Rosalba. So,
We count on
There's
you
no
for those.
silly.
All
There's
right.
no silly
Oh,
question.
yes, there is. You don't know Tarek very
you
well.
haven't seen these questions yet. Okay.
We
So
call him Dr. Clickbait. Sorry.
So
go ahead.
I was thinking about rogue planets a lot. You know, we talk about the science, a lot of which, you know, there's much. But I'm just wondering. I mean, as a human on Earth, you know, could we live on a rogue planet? So, you know, we find one of these things out there. Could we go set up a colony or something on it?
So it would be, since they are, by definition, being a rogue planet, very far, they're not attached to any star, we would have to have our own way to produce energy because we rely on the sun for light and for energy. So we would have to be super smart in order to be able to have, you know, to live without a source, you know, a source of light. So having our own, you know, way to, so that will be a big, you know, it's a big difficulty.
A challenge thing.
A challenge, right?
It's not like going outside in Los Angeles at night where you have like all the light pollution everywhere, where there's just ambient stuff there. If
Don't
we
be
could,
beating up on my city, my friend.
if we could, I lived there for 6 years, my friend. If we could live on one, I'm wondering what would you call. What would you call yours? I think Tarektopia sounds really nice, but if we could live on one,
Oh my God.
like, what would you
Oh my
call
God, that's an interesting. How would I call my free floating planet?
I hope for something lyrically Italian, maybe from opera, you know, like Tosca or something.
Tosca. It's actually the last opera I saw,
right.
so it was coming to my mind. As a matter of fact.
Oh, well, so Tarek, now I'm going to jump in, so because you brought up a good question, and then I'll let you get back to your list. If this rogue planet was a brown dwarf, and the moon was close enough, might that you know, say we had tidal flexing and some thermal energy coming from the brown dwarf, might that be enough to support life on the moon?
Right. So it again, it would depend because a brown dwarf, it's something that's hot for a period of time, but then it cool off very quickly because it doesn't have a real long-term source of energy, unlike the sun. So we may have by putting ourselves at the right distance for a period of time, we might have the right conditions, but they would not be as long-lived as for the sun, which lasts billions of years. So
Tarek, what she's saying is life would have enough time to evolve to where you and I are, but not to where she is intellectually.
That's awesome. That's awesome.
Hey, look what I found. How about that? It's my mouse pad. Okay, I'm sorry. Go ahead. For the audio listeners, I was holding up a CD of Turandot. Go ahead, Tarek.
Yeah. So this is something that some listeners might be wondering about, but I'm curious, could Earth ever become a rogue planet, you know, in the far future, or if we get a black hole that wanders by us, that kind of thing?
So the Earth, absolutely. So for the Earth, so the Earth is with the sun, which is it's a low mass star, our sun. So in general, if a planet is around a more massive star, so above 7 or 8 solar masses, then the star will end its life as a supernova. Now, when a supernova goes off, it releases a giant amount of energy, very sadly. And with that, the planets that were in orbit around the star can be easily ejected. Now, in the case of our sun, it will evolve into a white dwarf. So it's a slower process, but the Earth at some point will get very hot, and there will be, but there won't be an explosive event. However, if a star were to pass nearby, the Earth could be ejected. So, or even if it wasn't, maybe happen directly with it as a direct ejection, but it could, for example, if it makes the orbit of Jupiter be more unstable and then sets a series of dynamic instability within the solar system. And if that happens, the planets that would suffer the most and be most likely ejected would be the lighter ones.
Man, Jupiter just wrecks everything. Right?
Jupiter is actually responsible. We think of it just as a giant ball of gas, but it's actually responsible for for quite a few things in the solar system, including, well, some good things, for example, because there were a lot of objects moving around, and Jupiter sort of moved them in a belt, which is now protective for us because we don't receive as many giant asteroid impacts as in the past. So that's a good thing.
And I think I have time for one last silly one, and this is just about rogue planets in like sci-fi history. I'm curious if science fiction gets rogue planets right, like When Worlds Collide, the classic one. But I always wonder if like Endor, that moon of Endor, is like orbiting a rogue planet in Star Wars. Do you have a favorite sci-fi rogue planet to pick from, or is it just not as interesting as the real thing?
I've been following more the real things, I confess, than the ones in sci-fi.
There is an episode of Star Trek Enterprise where they land on a rogue
Okay, now I need to.
Tarek, while you were sitting in theater watching Star Wars for the 42nd time, she was doing her second postdoc. Okay,
It could be why we didn't get our astronomy degrees, Rod.
I think there's a lot of reasons for that. I'm sorry. Did we let you answer the question, Rosalba, or did you have more to say on that?
No.
Okay. All right. Let's go to our last break, and then we'll be back with my not dumb question. Stand by. So this is kind of a 2-for-1. Part of it's, I think, research that you may or may not have participated in, and then something you definitely did. So I read one bit about the Webb telescope being pointed at the Orion Nebula for just 35 hours. And the data from that amount of observations spotted, if I get this right, 42 pairs, so 84 rogue planets. And ultimately, I think, as you mentioned, spotted 500 of them. So that I thought was pretty amazing. But then you worked with a couple of other researchers to create a digital model to test some of your ideas. And I think it involved flying simulated star masses past simulated solar systems with Jupiter-sized planets, and discovered that it's not difficult to find conditions where two giant planets could depart as a pair. And then I guess they stay in a binary orbit around each other as they're slinging through dark space, right?
Right. So it's you summarized very well. So we did N-body simulations, so computer simulations, where we started with a system of a star and two planets, two Jupiter-like planets in outer orbits, and then had a close flyby of other stars happening and see what happened. And in the process, there are many single planets that are ejected, but also binary with a fraction of them. So we did find that if some binary planets can be formed through this process. It does require a specific initial condition for the planets, for the solar system, so they have to be already in outer orbits, because if you want to reproduce the observations of James Webb, these binaries were relatively large separations, so they are ready, and the separation in which they are ejected reflect the separation in which they were in the initial system. But something I should add is that the initial paper was more focusing on the creation mechanism. However, we followed up more recently with another work, which goes back to your second question, relates to the second question, which is then they have to remain as such in the outer space. And something that we see is that it's for a binary system, a binary made of two planets. It's hard to keep themselves as they are, so it requires because the other interactions keep happening. So if there was a certain likelihood of a star flying by for the original solar system, there will be also other stars flying by for the binary planet. So many of them will end up being disrupted over time, or the semi-major axis will change, and so forth. So it's actually like reproducing all 40, if they're real, if they are confirmed to be as such, because again, we still don't know, as Jupiter mass planet, it's actually non-trivial from a theoretical point of view. So the mechanism, it would require a very high production mechanism, because as again, we found more recently in this work, they get disrupted also at a very relatively high rate. So we're very much looking forward to the spectroscopic confirmation of this object, because right now, they could still be, misinterpreted as distant stars, or some could be brown dwarfs, and so forth.
Yeah, you bring up a really great point, because that was right into my next question. Rod, and you've been talking about all these different rogue planet candidates that have been found with James Webb.
Right.
And I'm very curious about what the biggest challenge is to finding them, because a lot of the methods that I'm familiar with that we've used just to find regular exoplanets is like we look for its effects on the parent star, right? Does it make a bubble?
Exactly.
Does it pass in front? And I'm
Exactly.
wondering what do you see as the biggest challenge to finding these things? And then how does something new like James Webb kind of change that challenge or make it a little bit easier?
Right. So the James Webb. So one thing that will allow indeed to be absolutely sure that these are planets and not other objects, not distant stars or brown dwarfs, is taking their spectra, and James Webb can actually do that. So detailed imaging of the objects, looking at their spectra. So if they're Jupiter-like, there will be trace of methane, other compounds that we know, water and other that we know they're part of the atmosphere. So these giants. So it requires spectra, and that's something for which James Webb has the capabilities to do so. So that will be on the front of this giant. On the other front of discovering planets via microlensing, there will be the Roman telescope that is going to observe many more with microlensing. So there will be another new world of discovery in a few years when it's being launched.
Yeah, that's the Nancy Grace Roman telescope.
That's right. Yeah,
that NASA wants to launch in October 2026, I think is
26 or 27. Yeah, something.
Yeah.
Right. So soon enough for
Keep our
astronomical
fingers
standards.
crossed and hope it doesn't get canceled along with so many other things. Tarek, you got more?
Well, I mean, I think just the last question that I would have is just about other research, like what are the pesky questions that, Rosalba, if you had a magic wand that you would be able to answer about these exoplanets. Like I always wonder how close to the planets we see in our solar system that they could be like, but then if they're wandering around without a star, it just seems like they'd all be just really frozen ice balls. So I'm just curious, like what other research what keeps you up at night about these objects out there in the void?
Yeah, I'm very interested in how they formed. So how did they get there? And because that relates also how planetary system formed. And the theory of planet formation are still very much still very much in development. We thought with the solar system that we had kind of the very basics, and we knew we understood for example related to these mysteries. We knew that Jupiter-like planets have to be formed outside a certain distance, which is called the frost line, where volatiles can be in the condensed form. And we knew that, and perfect Jupiter and all the others are outside. But then the very first planet that was discovered in 1995 had the Jupiter very close to the stars. So already, as we observe other systems, we see that the theory as we had it is it's largely incomplete. So what keeps me up at night is thinking of more the physics that goes on for a fuller understanding of planet formation on a larger scale. So beyond our solar system, our home.
So see, Tarek, that's one of the reasons you and I didn't become astronomers. She doesn't lie in bed at night worrying about her next session of that, whatever the hell that video game is you play on Twitch all the time. Rosalba, I guess for my last question, I was looking over your website at Stony Brook, and your list of research interests is longer than the last Costco receipt that I got, which is pretty long. Can you talk a little bit about some of the other things you're interested in and what you're working on?
Yeah, so My formation, so to speak, was in my PhD thesis was in gamma bursts, which are explosive events associated with the collapse of massive stars on one side, and another. There are two sets: the longer ones and the shorter ones, with the merger of two neutron stars. So I've always been fascinated by compact objects where gravity is extreme, and neutron stars, black holes. And now that we have observed the gravitational waves, I'm also very interested in the counterparts to gravitational waves that are produced when two neutron stars merge. That's an whole area of research. More recently, also in active galactic nuclei, which are very bright sources that we see in the distant universe, and in objects in their disks, so neutron stars and black holes that are harbored in there. So that's the opposite of rogue worlds. They are, we knew most of neutron star black hole, wandering in space, and here it's actually neutron star and black holes in a very defined location, which are the disks. So this AGNs, which then gives rise to a whole set of other interesting phenomena that I've been very curious to study recently.
Sounds like you have a real like for dangerous things.
Maybe, yes, I think so.
These things sound like they could be really bad for us. Well,
yes, the gamma burst that could be. I said.
Yeah, well, just make sure you're not on that side of the planet when it happens, right? So I want to thank everybody. You spent another hour with us for episode 126 of This Week in Space on rogue planets. Rosalba, where's the best place for us to keep up with your ongoing research efforts online?
I usually, all publications are, they are online. So, Google Scholar, IDS is the standard thing. And then sometimes, when things are being picked up by the press, they're written also in more friendly way.
Yeah, okay. I do understand. Well, so probably the best thing would be to set a Google alert just using your name, and that way you'll find the stuff that Tarek and I can understand. And speaking of Tarek, where can we find you battling the forces of first world water pressure these days?
Well, since school's about to start, maybe I'm going to go try and crash and audit one of Rosalba's classes in Stony Brook. So if you see me, just kind of look away, because I'm just trying to learn new things. Just ignore it, yeah. But no, you can find me on space.com, of course, as always, at on the Twitters at Tarek J. Malik. Maybe on YouTube at Spacetron Plays, where I'm going to try to play some games. New Star Wars game out this week, actually. That could be a lot of fun, Star Wars Outlaws. But we'll see. We'll see. Because there's the Fallout 76 season starts next week, and I'm nowhere near done with the current one. So we're gonna cram for Labor Day weekend.
And Rosalba, just so you know, if Tarek does show up to audit your class, you'll be able to spot him because he'll fall out of his chair at some point while you're teaching.
Oh my gosh.
That's an old inside joke. And of course, you can find me at pilebooks.com or at astromagazine.com. And a lot of my work is on the National Space Society website, and both that and space.com are good places to find all the best space stuff. Do remember, you can drop us a line at twis@twit.tv. That's TWIS at twit.tv. We love your comment suggestions and space jokes. Send your space joke. I know that people look adoringly at the sharp edge of their kitchen knife when they hear some of my jokes, but save your jugulars. Send us a space joke so we don't have to read mine, although this week's was pretty good. New episodes of this podcast published every Friday on your favorite podcatcher, so make sure to subscribe, tell your friends, and give us reviews. We'll take 5 stars, thumbs up, 6 sharpened knives, whatever you got. Just make sure that you tell the world you like us. And don't forget, you can get all the great programming with video streams on the Twit Network ad-free on Club Twit, as well as some extras that are only available there for just $7 a month. What else in life can you get that is this wonderful for $7 a month? So step up and be counted and help us out. You can also follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook and twit.tv on Instagram. Thank you very much. Thank you, Rosalba. We appreciate it.
Thank you very much.
Hope you'll come back and see us again. And we will see you all next time.